Hello, class. I'm going to start a video recording of chapter 9 of me going over the lesson 9.7, which is solving linear inequalities in one variable. And so I'm going to share my document camera with you. There we go. All right. So yes, so 9.7, solving linear inequalities in one variable. So we have here on page 126 of your workbook, it says a set of all real numbers between A and B is called an interval of real numbers. So then we have here this list of type of intervals. There's open intervals, closed intervals, half open intervals, open interval, and half open interval. Okay, so some of them are repeating. And then they have the algebraic notation for that. They have an interval notation. And then they have some graphs for that, okay? So we will be solving these inequalities and graphing them, making interval notations, and then we're also going to do a set notation, okay? So I don't really quiz you so much on the type of intervals, but I think the ebook kind of just asks questions. So you can see that on the open intervals that they have two sets of parentheses here. I saw another open interval over here that has one set of parentheses, okay? And these graphs extend, like this extends to infinity forever in the positive direction. This one extends to negative infinity forever in the negative direction. I see we have a closed interval. See, these use brackets. So brackets includes the endpoints. Brackets includes the endpoints. Parentheses don't include the endpoints. Parentheses mean the graph approaches the endpoint, gets very, very, very close to it, but doesn't actually touch the actual endpoint. So that's why they use parentheses. Whereas the bracket actually does touch the endpoint. And then you have something called half open intervals. So you can see that it's got a bracket and parentheses. So a bracket and parentheses. Okay. All right. And then there's some other information at the bottom that if you want to pause the video, you can do that. But I'm going to go ahead and start working some exercises. And you'll go through the learn on this page to familiarize yourself with that. I'm also going to let you go through the learn on page 127 as far as the addition principle goes and the multiplication principle goes. Okay, so you're kind of familiar with adding opposites already to move terms. And when we multiply, it's because we have a fraction coefficient and we want to multiply by its reciprocal. And then you're also familiar with these steps for solving linear inequalities. You want to, well, first there's actually a step 0 here, which is you want to do any distributive property. If you have it, you should definitely do that first. But then if you don't have it, or if you've already done it, Then you want to combine like terms on the left side of the inequality, combine like terms on the right side of the inequality. And it says in the steps for solving linear inequalities, these are not equations. These are not equations. You don't have equal statements. You have either these symbols, you have any of one of these four symbols, less than or equal to, greater than or equal to, less than or greater than. These are inequality symbols. Okay, so no equations. So you want to combine like terms on the left, combine like terms on the right, and then you want to start isolating your variable. Your goal is to put the variable on the left side, and then you have your inequality, and then you have your constant. That should be your goal. So when you're solving, your goal should be that you have your variable, and then your inequality, and then your constant. That's a must. That's a must. When you have an equation, they don't mind. When you have an equation, we just put this here. They don't mind if you put x equals 3 or 3 equals x. They don't mind when you have an equation. But when you have an inequality, they do mind. These are inequalities. They do insist that you have the variable on this side, on the left side, and then the inequality, and then the constant. So they're more strict for the inequalities because you have to graph and shade, and the sharp end, you know how these are like arrowheads, the direction that they're pointing, when you have the variable and then the inequality written that way, the direction that they're pointing is the direction that you'll shade on the number line. So that's why it's more strict. Because when you have equations, you're not shading, you're not making like shaded graphs. So you might be graphing lines that have X's and Y's, but for inequalities, you're shading number lines. Okay, so it's a bit different in graphing, and so that's the reason why they have the variable on the left side. And then you're familiar with the addition principle. In order to move terms around, you add opposites, either add or subtract both sides of the equation with that number to move terms. And then you're familiar with multiplication and division principle. So when you multiply, it's because you have a fraction coefficient. So then you multiply by its reciprocal. You multiply by its reciprocal. Okay. But if you're having to divide, it says or divide, if you divide, it's because you have either an integer or you have a decimal coefficient. Okay. And then yeah, so you would just divide by the coefficient itself. Divide by the coefficient itself. So if you divide, it's because you have an integer or decimal. So you would just divide by the coefficient itself. So in other words, don't try to do opposites on it, because opposites are only for this pair addition principle when you're trying to move terms. So here you're trying to move terms. So you add opposites. okay? But here, you're either dividing both sides by the decimal or the integer, or you're multiplying both sides by the, you have a fraction coefficient, so you multiply by its reciprocal. And then they encourage the check, which may not always be easy depending on your time constraints to do, but they recommend that you plug things in to see if you get a true solution. Is that true? Okay, so let's show you how to work these problems here. So it says graph each interval on a real number line and then tell what type of interval it is. Okay, so we want like to tell what type of interval it is. I guess I could go back to that sheet that had all those intervals. I guess I could do that. I don't always do that. I guess I could go back to this after we're done and then see which one type of interval. Is it open interval, closed interval, half open interval? So which one is it? That's what they're asking. So we have that. This is, if you read this out loud, this is read that X is less than or equal to -3. So I'm just writing that down in case you're not sure how to read that. This is saying that's a symbol. This is a symbol for less than or equal to. And so we'll start with a graph first. So I always plot 0 to give me some orientation. And then I will plot the endpoint, which is a -3, which is somewhere out here. And for in X is our unknowns. X stands for our unknowns. So our unknowns are, in this case, supposed to be represented by being less than or equal to -3. So that means that I have to shade, to the left of -3. If I were to shade to the left of -3, then that would say that the unknowns X's are less than or equal to -3. So I definitely want to shade to the left, okay? And then I need detail. We also need some detail on the endpoint -3. Do you go with a bracket or do you go with a parenthesis? So if you look at this underscore, the underscore, see a little line underneath there? There's a little line underneath the inequality. So the underscore tells us to include the -3 and use a bracket, not a parenthesis, but a bracket. I'm going to use a bracket on that -3. And when you make a bracket, brackets can look like this or brackets can look like that. So you want to shape it in the direction you're shading. So see how we're shading to the left? That means you want this bracket facing to the left. So that means that you want to use this symbol on the -3. Okay, that's your graph. Okay, and this is positive infinity over here. Well, this is negative infinity on this side. So you're graphing to the left of -3 forever in the negative direction. Okay, so that's your graph, and so we did that graph. Okay, then we're going to show you the interval notation. Okay, so I have to tell you some information about intervals. I think I'm going to do it on page 127. In order to do the interval notation, I should say a few words about the interval notation. So let me put that over here. And let's see. Let me start here on page 127. Okay. So I have that the interval notation is a snapshot of the graph's shaded region. Read from left to right. The other part of your definition I have to let you know is that because sometimes, not all the time, but sometimes on your intervals, you're going to have some infinities that shaded forever one direction. If you do have that, the shaded forever one direction, if you have those infinities, I need to let you know that by definition, all infinities use a parenthesis. So I'm not sure, I might have misspelled parentheses, but that's what this says, parentheses. So by definition, all infinity symbols use a parenthesis, which means do not include, which means do not include the endpoint. Yeah, so when you have parentheses, it means you don't include the endpoint. Yeah, so with infinities, it means like you're shading forever in one direction. Either you're shading forever in the positive direction or you're shading forever in the negative direction. So you can never capture an endpoint because it's infinity or negative infinity, and someone can always take it out farther. So you might say, oh, I'm going to take it out to -5. Well, someone say, well, I'm going to take it out further. I'm going to take it out to -10. And I'm going to take it out to -100. I'm going to take it out to -200 because it's an infinity or a negative infinity. So somebody can always take it farther out. Or somebody said, I'm going to take it out to 2. Well, I'm going to take it out to 20. Well, I'm going to take it out to 30. I'm going to take it far out, graphing as far as 50. Well, I'm going to take it out far out to 1,000. So you see, you can never end it an infinity because somebody can always come along and take it out farther because it's an infinity or a negative infinity. So that's when you use parentheses when you're not allowed to include the endpoint. Okay. And so the interval notation is a snapshot of the graph's shaded region read from left to right. Okay. So we take a look at that. Let's see. Interval notation. I'm going to put that up at the top. Number 5. Interval notation. Okay, so it's a snapshot of your graph and it's read from left to right. So the first thing you see is this arrow shaded in the negative direction. So see, that's negative infinity. So you need to do parentheses, negative infinity. You always need your endpoints or on the ends, I should say, on the ends of an interval notation. Your only two choices are, do I go with the bracket or do I go with the parentheses? So here you want to go with parentheses, okay, because you've got an infinity, a negative infinity, and they're all associated, remember, with parentheses. So you start off, oh, this is negative infinity, and you read it, purple, 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 all the way to a 3, and close it. So the interval notation is from negative infinity all the way out to 3, to a negative 3, excuse me, out to a -3. So from negative infinity all the way out to -3. Okay. So I have the graph, the interval notation. Okay, and then there's something called, we've done sets before, there's something called set notation. So I'm going to put some definitions about set notation on this page again. And I guess I will, is that okay? I don't know where to put it. I think I'll just maybe put it at the bottom. Let's see. Set notation. So first, let me say that all sets begin with braces. So all sets begin and end with braces, some kind of curly braces. Okay, it's the first thing you should know. And then, so if I do that here, they all begin and then they're going to end with curly braces. Okay. and then you introduce intro the variable, okay? Introduce, intro is introduction, you intro the variable, which means introduce your variable. So the variable you're talking about on number 5 is C, it's only X, okay? So you have X such that. So here, after you introduce the variable you're talking about, then you write X such that using the X such that. I guess I can say using the vertical bar. So what I mean by that is here on number 5, you see, we just had X. So X such that X such that introduce a variable, writes X such that using the vertical bar. There's your vertical bar. And then you're supposed to write, your solution. So that'd be number 4. You write your solution down. Write your solution down. Write your solution down. So I do that. My solution is this. It's like somebody already solved number 5 and 6. Somebody already solved it. They already did the algebra. So like if it had distributed property, they did it. If it needed to combine like terms on the left or right, they already did it. If they needed to use addition, opposites, move terms by using addition or subtraction property, they already did it. If they needed to divide by the coefficient itself, whether it's an integer or decimal, they did it. Or they had a fraction coefficient and need to multiply by its reciprocal to solve for X, they already did that. And so they did all that work. And now they're just telling you, look, here's my answer. Here's my solution. This is a solution. So what you do is step 4, you write the solution. And the solution is this, that X is less than or equal to -3. So number 1, offsets begin with braces and they also end with braces. So the offsets end with the other side of the braces. So this side. So here they begin with the braces, this one, and then they end with the braces. Okay. So that's what we have. It says begin and end with braces. Number 2, you introduce the variable. So the variable is X. You can see that here. Then number 3, you write X such that. So in other words, you write, I guess I should say you write just such that, because number 2 is already the variable. So on number 3, you're just writing the such that, which is just this little stick here. Shorthand, secretarial shorthand, legal secretarial shorthands, or paralegals use shorthand. I mean such that. And then using the vertical bar. And then number 4, you write the solution. And sometimes students say, do you really have to write X again? Like you have X here. Do you really need to write that X there? So I apologize because yeah, that's what they want. They want you to write the X or the variable, whatever it is again. So they do want you to do that. Okay, so you write your solution and then all sets end with curly braces. So then you end it with your curly brace. Okay, so that's your set notation. Okay. Okay, so here's your solution, here's your graph. And then we made an interval notation. And then the set notation. So we'll be doing 3 things for these problems. Oh, and you know, one major thing it's important to notice that I forgot, that I skipped on my steps. I need to go back. Go back to page 127. And one main new highlight is this that I just completely forgot and ignored, that is this right here. This part right here. If this coefficient is negative, be sure to reverse the sense of inequality. That means that if we divide or multiply by a negative coefficient, then we change the direction of the inequality. So you want to be alert to that, okay? And it only happens whenever you're solving inequalities, okay? So if the coefficient is negative, be sure to reverse the sense of the inequality, okay? And so you have to literally change the direction of the inequality when you recognize that. If you're multiplying by negative, or if you're multiplying or dividing by negative. So just keep that in mind. That's important. So let's see. Okay, number 6. So this is called a sandwich inequality. It's also called a compound. It's also called a compound inequality. So loose slang is sandwich inequality, but formal is a compound inequality, okay? So the thing is that here, the variable x is trapped. Variable x so variable x is trapped. So your variable x's are your unknowns. Your unknowns are trapped. Okay, so if I start off with my graph, and I put 0 just to give me orientation, and we have a negative 1.5, which is about right here. And then, oh, let me not put a marking here. Let me just put a tick mark, negative 1.5. And then 3.2, which should be somewhere out here on this side. Okay. So um, all our unknowns are trapped. All our unknowns are x variables are they're trapped. They're trapped. So I'm going to get my purple pen and I'm going to highlight in between negative 1.5 to 3.2. So negative 1.5 has a bracket. So remember, you want to shape it in the direction that you're shading. But then it also has no bracket, inequality symbol on 3.2, and no brackets. So that means it's going to be parentheses. Okay, that's your graph. And like I said, sandwich, it's a compound inequality. But see this underscore means to include the point. So I think I'm going to write that somewhere on your paper, somewhere on the previous paper. I'm going to say here, the underscore means to include the endpoint. Sorry, was I dozing off again? Oh, no. Sorry, sorry. Okay, I had a cup of coffee with me. I'm so sorry. Let's see, where were we? So the underscore means to include the point. Okay. And we did, see the bracket. So I can put here, the underscore means to include the point. You want to use a bracket. Okay, so if you don't have an underscore, no underscore present, if no underscore present, then use parentheses. So if no underscore is present, okay, so, oh, and okay, so use parentheses. Okay, so see here, see that there's no underscore. So here you have an underscore. So you want to include the point. You want to use a bracket. Whereas over here for 3.2, there's no underscore. So you want to use parentheses because there's no underscore. That means you want to use parentheses. Okay, and then there's the parentheses there. Okay, so there's your graph for that compound inequality. Okay, now for the interval, let's put the interval here. Remember we said about the interval on our interval notation that it's a snapshot, right? The interval is a snapshot of your graph. Okay, if they ever tell you to give you answers like and it's out of order, I would always go back and find the graph, even though they may not ask for it, to help you with the interval notation. Okay. So the interval is a snapshot of your graph of the highlighted, what's highlighted. So it's a snapshot of your graph, what's highlighted. So you see we start at negative 1.5, comma, all the way up to 3.2. And that uses C parentheses. Okay, so graph interval. Okay, all we need is a set notation. Set notation. So all the sets begin in with the curly braces. So you just so you have a set. So you have close interval. Okay, so remember the negative 1.5 included it. See, it had the little bar there, and it also included it in the points. So you have bracket negative 1.5. Okay, then you have all the way it closes to this infinity right here. And all infinities use parentheses. Okay, all infinities use parentheses. Okay, but there you have your pieces, your graph, your interval, your set notation. Right, see. Okay, so let's look at, see. Let's look at number 7. Solve each inequality and then graph the solution set. Which number solution set using interval notation? Okay, so let's see. So we're going to start solving. We're going to start solving these. Okay, so if you look at 7, you want to solve for x. When I isolate x, get x by itself, and you see how you have that +1 that's been added on to x. So you want to do opposites. Opposite of a +1 is a -1, and the ones fall out. So then you have x is greater than -7. Oops, -6, right? Let's see. Well, let's see, sorry. What is 5 minus 1? -1, 5 minus 1 is 4, right? 5 and take away 1 is 4. Okay. So we did solve it. This is what we got. That's our solution. Solve it as your solution and then graph it. So I'm going to draw a number line. I'm going to plot 0, and then I'm going to plot 4. Okay. And this is saying all your x's are greater than 4. So you would have to highlight unknowns that are bigger than 4. And you need detail on the 4. So notice how this is open parenthesis. So you need to use parentheses. Okay. On that 4. So you have it's greater than or equal to 4. Okay, so it's a graph. Okay, let's do the interval notation, which is a snapshot of your graph. So take a picture of this interval, make a snapshot of this, and you're graphing from left to right. So first you see parentheses 4, comma, and then you see the bok choy. So what did I say, bok choy? Infinity. Yeah, bok choy is a it's a vegetable that you use like in your stir fry. So your graphing is x is you're graphing everything greater than 4 all the way to infinity, out to infinity. So this is a snapshot of your graph, and you read it from left to right. So you read 4, and then comma, and then all the way to infinity, and then use parentheses on that. Okay. So remember we said somewhere that all infinities, somewhere we wrote that all infinities use parentheses. Okay. All right. Oh, now we need our set. Excuse me, our set notation. All sets begin and end with curly braces. You introduce the letter you're talking about, which is X, such that, and then you write your solution, which is X is greater than 4. Close that. Okay. Let's try. Let's try 8. Okay, so with 8, notice how you have, if you read out loud, negative 2x is greater than or equal to 6. Okay, so in math, we say that we undo multiplication and we undo multiplication by division. So we're going to divide both sides by -2. And when you do that, you divide one side by -2, you're going to have to, and this is divide both sides by -2, which is the coefficient. Okay, and they didn't say divide by opposite. Like they didn't use the word opposite. They didn't divide by +2. They didn't do opposites. They did the same thing, -2, -2. Divide both sides by -2 coefficient. Okay, and you do a little bit of cleanup, a little bit of simplifying. Like for example, -2 divided by -2 is 1, and -2 goes into 6 3 times. So you have your graph. Graph and set. What are we missing on this one? Oh, the interval. I wrote this here, but that doesn't look like the interval. It is from 4 to infinity, shaded forever in the positive direction. Okay. Sorry, class. I'm dozing off again. Sorry. So let's see. Divide both sides by -2, which is the coefficient. And then you're going to have to change the direction of the inequality. And why would you do that? Because we divide it by negative coefficient. Change direction of inequality because we divided by negative coefficient. Yeah, so right here I'll have x is less than or equal to 3. X is less than or equal to 3 because you have to change the direction of this inequality, change it to the other direction. And because you divided both sides by the -2 to isolate the x. Okay, so now let's see. Number 9. Let's see. So on 8, we did the interval is still good. So 8, we need the graph. Okay, so we need the graph for 8. So we draw a number line. And plot 0, give me orientation. And I'm going to plot that 3 there. And this is saying all your x's are less than or equal to, So that would be that we'd have to shade this side to this left side of -3. See how this is pointing to the left? So shade to the left. And then you need, this 3 needs detail. And to get the detail, you just you go to your 3 and you see how it has an underscore. So you have an underscore. And the underscore means use a bracket. And I put a bracket so it's shaped in the direction that I'm shading. Okay, so I did the graph. I need the interval now. The interval is a little snapshot, right? Little snapshot, right? A snapshot of your graph. So we read it from left to right. Okay, and I think I put that over here. Did I put that over here? Let's see. Did we say that you read? Yeah, read from left to right. Yeah. So we read this from left to right. So you see, this is negative infinity, right? Negative infinity. This is positive infinity, which we don't need. Nothing is shaped over here. This is negative infinity. So you do parentheses, negative infinity. Because remember, all infinities start with parentheses. So the negative infinity all the way to here, which is a bracket, which is grouping symbols. Okay. And so we went from negative infinity all the way to 3. Oh, I'm noticing on the 3 that we should have a bracket on the 3 because we said here use a bracket. Yeah, so we should have a bracket on the 3. Parentheses on the infinity, negative infinity, but a bracket on the 3. Okay. Okay. Okay, now we need the set notation. So all sets begin and end with curly braces. You introduce the variable you're talking about, so you can see that they're using X. And then such that the bar is such that, and then you write your solution, which is this, that X is less than or equal to 3. Then you close it, okay? So the set does have, you're supposed to get like a solution from that or see the solution in that problem. Okay, let's look at number 9. Excuse me, 4x minus 7 is greater than or equal to 9. Okay, so first you want to start by isolating the x by itself. So you want to move the minus 7. Opposite of minus 7 is a plus 7. And so you have now that 4x is greater than or equal to, and 9 plus 7 is 9, 10, 50, 60, 60. Okay. And then to solve that, you divide by 4. Four x is greater than or equal to 16, so you divide both sides by 4. And these are 4 out. And 4, you know your multiplication charts, 4 goes into 60 4 times. Okay. All right. Just double checking. So okay, so let's see. Sorry, we're dozing off again. Sorry about that. Let's see. So we did 9, we solved it. And did we graph it? We haven't done a graph for it yet. Okay, let's do the graph. So I'm putting 0 for orientation and then a 4 tick mark. And this is saying all the x's are greater than or equal to 4. So that means I'm gonna have to shade to the right and the arrow tips. X is greater than or equal to. So then you need a bracket and you have to shape it in the direction that you're shading. It does need to be shaped in the direction that you're shading. See, the shape to the right. Okay, here's your graph. And then you have your interval. So your interval is a snapshot of your graph. So you graphs, you read it from left to right. First started with brackets 4 and then extend it all the way to infinity. Infinity and forward from 4 to infinity. So that's what this is, interval 4 to infinity. And infinity, you want to use the close parenthesis on that. So then you need to set again in the braces. And you introduce a letter which is x such that, and you say that x is greater than or equal to 16. Oh, greater than or equal to 4, sorry, greater than or equal to 4. Okay, so there's your graph, interval, set. Okay, now let's go to 10. Let's go to 10. Okay, so 10, notice on 10 how you have two variable terms, and notice how you have two constant terms. So you're going to want to use the addition property or subtraction property like twice, where you move terms around. So for us, I would feel comfortable moving the 2x. So the opposite of a 2x is a minus 2x. Take away 2x. And the 2x's fall out. 5x, take away 2x is 3x plus 6 is greater than or equal to, what's that number? Let me see, we use 2x minus 2x, 5 minus 2x is 3x equal to right minus 2, right? That's what's left over. You're just bringing this down. Okay. And then now you're going to move the 6. You're going to subtract 6 on both sides. So then you have 3x is greater than or equal to. Okay, so I move the 2x's up, the 2x is minus 2x. And now I move the 6, opposite of plus 6 is minus 6. And negative 2 and a negative 6. Remember, there's like a little plus sign here, if you will, right? That you can put there if you want, no plus sign there. But other than that, negative 2 plus negative 6 is you just add and keep the negative sign. So that gives you a negative 8. So I should have 3x is greater than or equal to negative 8 is what I should have. Okay, now I'm going to divide by 3. Divide by the coefficient. So I'm going to divide both sides by 3x. Oh, just by 3, just by 3. See how these cancel? And then just to see what's the value of -8/3. If I just put that into the calculators to get an idea of what it is. -8 divided by 3, -2.6 repeating. So if they want you to use decimals, they'll tell you what to round to. So if I round this to two decimal places, tens, hundreds, look at the neighbors of 5 or more, yeah. So add 1 to this, 2.67. So x is greater than or equal to -2.67. Okay, or you have the improper fraction, or you have the mixed number. If you do 3 divided by 8, no, the top number goes inside the house. So this is wrong. The top number is 8, goes inside the house. -8 divided by 3. 3 goes into 8 times. 3 goes into, and I know it's negative, so move the negative off. 3 goes into this 2 times. But so let me box this and this. And as a mixed number, it goes like clockwise. So x is greater than or equal to 2 2/3. 2 2/3. So 0. So this is your mixed number. Mixed number. This was improper. Okay, and then when you graph that, when you do your graph for number 10, draw a number line and plot 0 to give you orientation. And when I plot that endpoint of -8/3, which is like a little bit, well, it's up -2.67. So let's see, here's -1, here's -2. This is, go one more out, -3. Okay, so -2.67 is a little bit past -2.5. So here's -2.5. So, but it's about like right here. Okay, it's about like right there. -2 2/3. So you want to shade, let's see, x is greater than or equal to it. You want to shade to the right of it, it's greater than. So you want to shade, it's bigger than. X is greater than or equal to 2 2/3. Oh, and it's a negative, right? -2 2/3. Negative. So it's about right here, -2 2/3. -2.6, okay. And x is bigger than. And see on the negative, on the -2.67, this is approximately, if you round that to the nearest hundreds. See how you have the underscore? You have the underscore. Underscore equals that you have to use a bracket. And so you have to shape it. So shape it in direction. Shape it in direction. So That's supposed to represent about negative 2.67. Okay. So I guess I could put negative 3 a little bit after, like maybe right here. So it's about negative 2.67. It's definitely past negative 2, but before negative 3. So it's just an approximation. But there's your graph for that. And then the interval, it's a snapshot. The interval is a snapshot of your graph. And you read it from left to right. So you start with bracket at the negative 8/3. I'm going to just use the original, this one. The tolerance should be high. So if you can put the mixed number, if you're able to write that in on the palette. So, you know, mixed number needs these, right? Look, if you have those on your palette. If you put the decimal, it's only because they will tell you, oh, you can use a decimal, but you got to round it to a certain place value. Because remember, the other one was repeating, remember? So you can't write it like that, repeating. And you don't, there's no way to put a bar, you know, we have this bar like this, right? That's also true. But I think in your little palette, there's no way, I think, to show that. So that's why you would have to round to whatever place value they tell you. And then, so you read it from left to right. And so then you have this infinity. So this is infinity. And then you use parentheses on that. Okay. And then we need the set notation. So the set notation is all sets begin with braces, and then you introduce the letter you're talking about, which was X, and then you have the such that, and then you write your solution. These are all your solutions. So I'm going to just put the one with the X is greater than or equal to negative 8/3. I'm going to use that one. But that's your set notation. So let me just double check that because I was dozing off. Let me go back and just check them. Excuse me. Yeah, I don't see any errors. I think we're okay. I don't think I made any errors. So I'm just double checking because I was dozing off. Okay, so they got that page done. Okay, then we're also going to do, let's see. Let's see which ones. The math department needs some as well. Let's go to this page. Let's do these. Okay. Let's do those. All right, so they're asking us to determine which number numbers are in the given interval. So this is an interval notation. We have a bracket, 9/2, all the way to 8. So you're like, well, what's the value of 9/2, right? I'm just curious, what's that value? So if you go with your calculator, I'm using my graphing calculator, I should be using your multi-view, sorry, your multi-view calculator. So 9 divided by 2 is about 4.5, okay? So this is the same thing as saying bracket 4.5 infinity, close parentheses, okay? Also, if you wanted to do long division, 9 divided by 2, because the numerator goes inside the house. 2 goes into 9 about 4 times. 4 times 2 is 8. 9 minus 8 is 1. That's your R, your remainder. And this goes clockwise. So this would be 4 and 1/2. So another way to write this is bracket 4 and 1/2, comma, infinity. Close that. Okay. Okay. All right. Okay, now let's see. So you really need to draw a graph to help you, even though they don't tell you to write a graph. This is an interval, but remember what an interval is. An interval is a snapshot of a graph. So because of that, you really should draw a graph, even though they don't come out and say that. And you just put 0 to give an orientation. 4.5 is, okay, let's do 1, 2, 3, 4. So 1, 2, 3, 4, 5. Let me just make this longer. And it's 4.5, which is 4.5 is about right here. Okay, that's, which is the 9/2, okay. And it's about right here. And we put some negatives on the side, -1, -2, 3. All right. And this is saying that it starts off at 4.5 and then it goes on to infinity forever in the positive direction. So if I do my shading, I want to shade like from here, 4.5, all the way out to infinity. Okay. And this calls for a bracket. I need a bracket at 4.5. So this turns into a bracket. Okay. Yeah. So we don't use like open circles and closed circles. Maybe in high school, maybe you, if you remember some of this from high school, they might have used open and closed circles, but we only use, your only choices are really just brackets or parentheses. We don't use open and closed circles because we have to also make an interval notation. And that's the reason why the parentheses and the brackets are more helpful because of that, okay? So we use brackets or parentheses, okay? So this is the graph for this interval. These are intervals. This is the graph, okay? So the interval is like a little mini picture of the graph, okay? So when you go through the motions of which numbers are going to be in here, you want which ones are in this interval, you want what's in the shaded region. So you start with 9/2. Well, you know already 9/2 is 4.5 from this work here. you know it's 4.5. So is that something that's shaded? Is that something that's shaded included? Is that included in this graph? And I would say, yeah, it's right here, right on the end, and it's a bracket. If it were parentheses, I'd say no, but it's a bracket, so I would say yes. So yeah, so I would say that it's the end point of the graph, and then it's a bracket. So I would say yes. Determine which numbers are in the given interval. Yes, it's in the interval. Okay, now I go to B, which is 13 halves. Okay, so 13, what's 13 divided by 2? 13 divided by 2 is about 6.5. And if I wanted to make a fraction out of it, 13 divided by 2, see how the numerator goes inside the house? 2 goes into 13 about 6 times, because 6 times 2 is 12. And 13 minus 12 is 1R. So you know how this goes clockwise like that? It's the clock. So this is actually 6 and 1/2, and they're all positive. Okay. So that's where that's at. So where is 6.5 in your region? If you look at your region, 6.5 is somewhere over here, right? This is 5. So then this would be 6. So if I put 7 here, yeah, so 6.5 is probably like about right here. 6.5. So yeah, it's in the shaded region. So yeah, I would circle that. And I would say yes, it's in the shaded region. Yeah. As long as it's in that shaded region, it's a solution. Okay, what about 4? See, 4 is right here. And doesn't that look like it's outside of this purple? See, it starts right here at 4.5. So even though it's very close, there's a little gap there. See it? 4 and 4.5. So yeah, I would say no. No, 4 is not in the shaded region. Then you have a half. Where is a half? A half is, 0.5, right? And so it's just one of those two choices. So that's about, see here where 1 is, that's about right here. That'd be about 0.5, which is about a half. So that's not in the shaded region. I would say no. No, not in shaded region. And they want to know which ones are in the region. So just these two, A and B. Okay. All right. So make it a habit to, when you have an interval and a graph, like make it a habit to do both graph and interval, and then you can answer questions about that. It's going to help. Okay, now if you look at 2, consider the following inequality. And this one has Z's. You know how a while ago we had a whole bunch of X's? Well, this one's got a Z. So when you make your set notation, open braces, you want to have Z such that. So when you get ready to make your set notation, curly braces, Z such that, and then you put your solution, which we have to solve. We're going to solve that right now. So it says write the solution using interval notation. Okay, well, we can't just jump to interval notation without first solving first you have to solve it. So you want to isolate v, get z by itself. And I would move the +4. The only way to move it is to do opposites. -4 on both sides. So then you have -2z greater than or equal to, and -6 plus a -4 is a -10. So then you have -2z greater than or equal to -10. So if you ask, well, how do you finish solving that for z in math? We undo times by division. So you divide by a -2 on both sides. So I'm going to divide this by -2, this by -2. These fall out. Greater than or equal to. And -10 divided by -2 is +5. So you have z. Oh, and you know what else happens? You have to change the direction of inequality. So you have to be careful. You have to change the direction of inequality because you divided by a negative. So divide by -2 and you want to change direction of inequality because we divided by a negative coefficient. So that is, remember when we had these steps, remember on page 127, we had these steps. That was this, if this coefficient is negative, be sure to reverse the sense of inequality. That means that if we divide or if we multiply by negative, the coefficient, a negative coefficient, then we change the direction of the inequality. So I'm saying that we did divide by a -2, which is a negative number. So we do have to change the direction of this inequality, which bounces back to z is less than or equal to 5. Okay, so solving it. Okay, so now what? Let's see. Write the solution. Use. Okay, so I think these steps are out of order. They want an interval on step 1, and then they want a graph. I think really this should be step 1, and then this should be step 2. I think it's kind of out of order in my opinion. You should do the graph first. So if I just plot 0 to give me orientation, 1, 2, 3, 4, 5, 6, 7, -1, -2, -3, -4, -5, -6, -7. Okay, and you have 5. This is saying z is less than or equal to 5. So 5 is right here. So to say that it's less than means we have to shade to the left this way. Less than or equal to. So equality on 5 is this bracket. Instead of the parentheses, you need the bracket. If you didn't have the underscore, then you do parentheses. But because you have the underscore calls for a bracket. It to include the end digit, so that we're going to include the end digit of 5 with a bracket because it's got the underscore. So I would do the graph first, and then I would go back and then do the interval. Then I would do the interval. So this is your graph. Then do the interval. And then after the interval, then you can do your set notation. Okay. So we'll do the graph first, and then the interval. Then you'll have some time left. Okay, let's see. So interval is a snapshot, and you read it. Remember how you read it? You read it. It's read from left to right. So you read it from left to right. And this is negative infinity right here. So you have negative infinity, comma, to, looks like 4.5. Or no, that's 5. It's 5, right? It's 5. Endpoint is 5. So negative infinity to 5. It's your interval. Okay. Negative infinity all the way to 5 brackets. See? And then the set notation, all sets beginning with braces, and you introduce a letter. So we're talking about Z, such that, and then you write your solution. Z is less than equal to 5. And close it. Okay. Okay, let's look at the next page. Okay, 3. I'm gonna do 3 because you probably will have one in your Hawks Learning homework in the practice. Maybe not everybody will get it certified because I think it like randomly generates the problems, but you will have to do it in the practice. But on a test, I wouldn't pick one of these to put on a test only because it's so long, because it also has fractions in inequality. So I wouldn't put something like that on a test. But other ones that we've done so far have all been really, really good. All the ones we did on page 133 and on page 130, all those possibilities. But I'm also not going to skip 3 because you're probably going to see that in your practice, okay? So it says, state the following linear inequality, or solve it. Write your solution in interval notation and graph the solution set. Okay, so we're going to solve it, interval notation, graph, and solution. Okay, so let's see. So what you want to do first is, because you have all those messy margins, all those fractions, what you want to do first is clear your fractions. And the way you can do that is by multiplying each term by the LCD, which should also be the LCN. So in order to do that, you look at your denominators, which you have 4 and 3, and this one doesn't count. This one is an imaginary 1, but we don't count that. You just look at 4 and 3, and 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 5 times 1 is 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. Okay, so it looks like the LCM, which is the LCD, looks like it's 12. Okay, so I'm going to multiply this by 12, this term by 12, and this term by 12. Okay, so the first term, multiply that by 12 and change my ink. 12 over 1 is equivalent to 12. It's less than 12 times this term, x minus 3 over 3. Let's see. This should be a 2. And I'm going to leave off. This one didn't have the imaginary 1 underneath there, so we can actually leave it off. You can put it if you want to, but you can leave it off too. There's no harm in that. And I'm going to multiply that by 12. Instead of 12 over 1, just by 12. I'm multiplying this by 12, this by 12, this term by 12. Okay, so 4 goes into 4 one time. And 4 goes into 12 3 times. Okay, so now what you have left is 3 being multiplied with this binomial. So I need to put that in parentheses. And what's happening here is 3 is going into 3 one time. 3 is going into 12. Four times, right? 3 goes into 12 4 times. So you have this is your inequality, right? Listen. So you have 4 times x minus 3. And then plus, and then 2 times 12, which is 24. I'll just check that out. Okay, everybody ready? So now we're going to do distributive property. So 3 times 2x is 6x. 3 times a positive 5 is 15. Less than or equal to 4 times x is 4x. 4 times negative 3 is negative 12. Let me check that, make sure no mistakes. Okay, looks good. Okay, so now these I can combine negative 12 plus 24. So, combine like terms on the left side. combine like terms on the right side. So negative 12 plus 24, you technically you'd have to subtract 24 minus 12. 4 minus 2, 2 minus 1. And you keep the sign of the number with the larger absolute value. So it looks here like 24 is the larger absolute value. Okay, so we get a positive 12 out of that. So we have 6x. Let me make it lower so it doesn't interfere with the number line. 6x plus 15 is less than 4x. And then you just told me negative 12 plus 24 is a positive 12. Okay, and now I'm going to move the 4x over by using opposites. And these fall out. 6x minus 4x is 2x. Plus 15 is less than 12. And then now I'm going to move the 15 over. So I have constants, all the constants on the other side. 12, 13, 14, 15. It looks like a negative 3. Is that what you got? And then now I'm going to divide by coefficient. So I'm supposed to divide by the coefficient. So divide by 2, right, class? And does the direction of the inequality happen? No, it stays the same. And the value of 3/2 is what? Let's see. 3 divided by 2. 1 and 1/2, yeah. Okay, so we're gonna do the graph. The graph is up here. So I'm gonna just put some numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Okay, so x is less than negative 3/2. So, which is, remember it goes counterclockwise. So x is less than negative 1 and 1/2. These are all valid solutions. Or if you do a decimal, I believe that would give you x is less than negative 1.5, even as a decimal. So for our graph, 3/2. Okay, so x is less than 1.5. So it's a negative. So here's negative 1, here's negative 2. So negative negative 1.5 is in between -1 and -2. And it says that it's less than. So you want to shade X the unknowns, all your unknowns are less than -1.5, and you want to use parentheses. Okay. So there's the graph for that, and then we just need to make, okay, and these are solutions, right? We have solutions, and then we have the graph. Okay, now we need the set notation. All sets begin and end with curly braces. And you introduce the variable we're talking about, which these are x's in this problem, such that. And then you put your solution, which is x is less than -3/2. So there's your set. Graph and your set. And where's your interval? Okay, so the interval, it's a mini snapshot of your graph. You read it from left to right. So you're going to see -infinity first. So parentheses, -infinity, because it's parentheses. So -infinity all the way to -1.5. Okay, there's your interval. And I think maybe they weren't, okay, if you don't want to use 1/2, you can use -3/2. That's originally what they had there. Okay. And that's your interval. Okay, I think we got everything. The set, the interval, the graph was up here. Those are your solutions. Okay. Okay, and then sometimes you're going to have some application problems, some story problems, applications, where you want to set up the inequality. So I do have a list of vocabulary, and the vocabulary, I see it right here. See the word at least, see that? That's vocabulary. So let me just show you the sheet. I have the sheet in your modules. You look through your modules, let's see. And you can put some of the words down on your paper if you want. See this sheet here? Okay, it talks about when you change the direction, of the inequality. Whenever you're multiplying or dividing by a negative number, or if you have to swap left and right hand side. So you always want to make sure the variable is on the left side. Variables on the left side. So you always want to move things and set things up so the variables on the left side. Okay? Because otherwise that will prevent you, from shading correctly, for example. Okay, so we were looking, what we say the vocabulary word was? It was at least. So if we look for at least. Here it is. See right here? At least, see the symbol right here? I'm going to write that down with the greater than or equal to, greater than or equal to. So I'm going to write that down here. Okay, so let me do this first. So the format for these is you want to have the variable and then the inequality and then the constant. So for us, the inequality is the vocabulary at least. And we get that at least here, which is this symbol right here. At least 208. Okay, so there's your constant. See, at least 208. There's your constant. Okay, now what y'all could do is like if you were to pause the video, you could, you have to write your symbol and then your vocabulary. We found at least over here. So like what you could do, for example, is somewhere probably if you do that, you should probably do that on one of those 2 pages that have the directions. So like either this one, page 127, or the one before that, like for example, 126. So somewhere you can, those are all pretty loaded pages, but that you could squeeze your vocabulary word in there somewhere. So like, let me see. Like, I guess if you wanted to do this here. So if you have this inequality, then you can write greater than or equal to at least no less than a minimum of. Okay. And then like to write the other vocabulary, like for this one, less than or equal to. So this one's greater than or equal to. Okay. And what I could do is somewhere on the side, maybe at the top for the other one, do less than or equal to. So here at the top, that's less than or equal to. So that would be, okay, well, that's the first one, less than or equal to. So I already wrote that. At most,